Now that we've established the difference between coarse and fine-grained soils, we can dive into discussing the angle of internal friction, or phi. Coarse-grained soils typically rely heavily on angle of internal friction for capacity, while fine-grained soils rely more on cohesion. Theoretically, pure clays will have a phi angle of 0, but this value will slowly increase with the presence of sand. And I've drawn out some typical values for you. Usually coarse-grained soils will have between 25 and 45 degrees, and fine-grained will be in the 0 to 20 degrees, with that increasing as there is more of a component that is sandy or gravelly. Angle of internal friction is exactly how it sounds. This is the angle at which failure occurs in a response to a shearing stress internally. This is commonly combined and sometimes mistaken with angle of repose, which is the natural angle at which a pile of that soil or that type of soil would settle to. This, in a way, is the angle of internal friction because it is the failure angle under self-weight. But the angle of internal friction is commonly found by the triaxial shear test, and some variables that affect phi are, when you're doing this test, are grain distribution, the angularity of the particles, and particle interlocking. If we draw a chart with shear stress on the y-axis and principal stress on the x-axis, which is, as we discussed before, the stress normal to the x and y planes of, say, a 2D soil cube or 2D soil rectangle that I've drawn here, we will get a failure envelope that is some function of the principal stresses and the shear stresses. This failure envelope is drawn using Moore's circle, which I won't discuss in detail here. But the angle of this failure envelope is our internal friction angle. And we assume that coarse-grained soils are cohesionless, so we'll start at that 0 point, that 0, 0 point, drawing out that envelope.